Alright gang, we're going to do section 1.7, and I think this is fun stuff. You may not agree with me, but I think this is fun stuff because the graphs look fairly complicated, but by the time this is done and over with, you guys are going to know how to graph these things no problem, and I think it's fun. You can call me crazy if you want. I'm sure many of you already have. I'm going to break this into 3 parts. Okay, the first part is just going to be vertical and horizontal shifts. Remember, those are referred to as rigid transformations. Second one is going to deal with non-rigid transformations. And remember that the non-rigids are the ones that make the graphs skinnier or fatter. And the last one is going to be about reflections. And I'm going to have a whole lot of practice in here for you guys to really hone your skills on. You will need some graph paper. Right, and remember that the transformations are going to be all in the same basic format, which is a, and then in a bracket, f of x minus h plus k, and the a, the h, and the k all have a meaning to us. Okay, a is the one that makes the graph skinnier or fatter. Okay, in addition, if a is negative, that means there's a reflection across the x-axis. H moves the graph left or right, and K moves the graph up or down. All right, so this is how you dissect these equations. You have to recognize that that hard bracket is basically your parent function. The fact that there's an H in there shouldn't confuse you at all. That bracket's just a parent function, so it could be a square, it could be a square root, it could be an absolute value, any of those things. Okay, so for example, I have 2 that are right here, and if you look at the parentheses, there's not a bracket there, that was just because there were 2 parentheses. If you look at the parentheses, it's a square function. All right, so you're going to do every transformation to the parent function, which is a square function. The second one, the parent function, is an absolute value function. All right, so let's get started here. All right, let's say in this example that we have the parent function y equals x squared, which looks like this. And don't forget those 1, 1 points. What will the transformation shown by that equation look like graphically? There's 2 transformations here. The first one, inside the parentheses, moves the graph right 2 spots. So what I want you to think of, and I'm going to show the whole graph sliding around on here, but when you're making these graphs yourself, just think about the vertex. Just think about that point moving, okay? Because I'm going to have you think about it 2 different ways. Just move that point around and then draw your graph when you're finished. But also, you can think of moving the entire axes. I'll show you that in a second. All right, so I'm going to move right 2 spots. All right, and then that second transformation moves it down 5 spots. And again, you have your 1, 1 spots on there. So when you're doing this by hand, you're not going to take the whole graph and move it, but you're going to have the vertex, you're going to slide that right 2 spots, and down 5 spots, and then you're going to draw your new graph, paying attention to the 1, 1 points. Okay, like I said, another way to look at it is we're taking the entire axes and moving them right 2 and down 5, and that's helpful when we come across reflections, because the reflection is the last thing that you do. Yeah. If we have reflections, we will address soon. The reflections occur across these new axes. Fantastic. Okay, let's take this. Our parent function is the square root, and it's drawn there. And let's figure out what the transformation looks like. Okay, first of all, that tells us to move it left 6 spots. So it's going to move to there. And secondly, the 2 means that we're moving it up 2 spots. And remember that 1, 1 spot. That is our final graph. And you don't have to redraw the axes. I'm just doing that for a visual sense. All right, so that is how we deal with rigid transformations. In our next video, we're going to talk about non-rigid transformations when there's an A value. Adios.